Hi and good evening, everybody. If you've joined us for the first time, my name is Anand. Most of you would already know me. This is session 8 of our IPM Quant Booster series. Today we're going to look at the topic of complex numbers. Welcome to our channel. If this is the first time you're viewing us, please make sure that you subscribe to our channel, that you like our videos, do watch all the videos. I've tried to sort of give hashtags. So click on the hashtag given below, IPM Quant Booster, Eptitude Quant Booster, and you will be able to view all the videos in this lecture series. And if you guys can hear me, can you give me a thumbs up or give me a, just let me know in the chat if you guys are able to hear me loud and clear. Good evening, Siddhant. Yeah, is the audio coming off well? Are you guys able to hear me? Hi, Kriti. Right. Okay. Some of you have already acknowledging. So, okay, seems like the setup is working all fine. How are you guys doing? We had a vocab session on Tuesday, right? So I hope you guys enjoyed that. Vocabulary is an important area in all exams, and through the course of about 15-16 sessions, the idea is to sort of enable you to learn and memorize not just words, but also a good technique to go with this, right? To follow in for such cases. Right. Okay, so our topic for the day is complex numbers. I'm sure you guys have all studied this in class 11th, was it? Well, I mean, I don't know if there is a proper definition for complex numbers, but I'd say that you can think of number properties defining numbers as either real or imaginary. So real numbers are those which can be plotted on the number line. So anything that doesn't can't simply be plotted on the number line is an imaginary or a complex number. These are numbers which obviously contain the iota, right? Iota being the moment complex numbers comes into play, we'll start thinking of iota, which is square root of -1. So any number. Yes, Mohit. Can you guys please check if the exercise is available on the portal? I think I did enable it just before I logged in today. So I mean, it should start showing up now in your online accounts, right? Can you guys please check? Sorry for that. In the meanwhile, what we can do is we can quickly sort of revise the basic concepts within complex numbers, right? So everybody knows that a complex number will have any number, complex number z can be written as x plus I into y. X is the real part of the complex number and y is the imaginary part, right? Iy is the imaginary component of the number. How many of you remember the Euler's form of representing a complex number, right? Euler's form says if a complex number z is written as a plus ib, then you can also write this as a into cos theta plus I sin theta, and the third form for this is a into e raised to the power I theta, right? So now if you compare the two, then you have something called a, which is the modulus for a complex number, right? So basically, complex numbers have a lot of linkages with coordinate geometry. And why is that? Because in coordinate geometry, you start thinking about plotting a point on the x-axis and the y-axis in the two-dimensional plane by using these two coordinates, right? So for a complex number, there will always be two coordinates because the complex number will have a real part and an imaginary part. So what you can do is you can take x and y and plot it on what we call the Argand plane, much like the coordinate plane, right? Much like the 2D plane that we usually plot numbers on, right? And this plot, if you plot x comma y, a point x comma y which corresponds to x plus iy, then you'll see that the distance of the point from the origin will actually be nothing but, this is going to be x and this is going to be y. So the distance from origin will be root of x square plus y square. So what we understand as the distance from origin, the distance formula, right? But for a complex number, what that will mean is its modulus, right? So the first sort of thing when you're dealing with complex numbers is to know that the modulus of a function of a complex number is equal to the sum of squares of its real and imaginary parts, right? And obviously you can also calculate something called the argument, and this also has linkage to coordinate geometry because argument is theta. This is the theta that you're calling the argument, right? So, and that's the theta that also gets used in the Euler form. So what is theta? So obviously theta will be tan inverse y by x. Theta will be tan inverse y by x, right? So if I give you a number in the normal form with the real and imaginary parts being, integers or rational numbers, then you can very easily derive the modulus and the argument for that function, for that complex number. And you can also represent that complex number in the Euler's form, right? Now, this is the very, at a very, very basic level. Obviously, besides knowing what a complex number is, you should also understand what is the conjugate of a complex number. A conjugate or Z complement is basically when I reverse the sign of the imaginary part. So x minus iota into y will be the conjugate of Z, right? And one of the most popular formulas that you use with complex numbers is that if you take Z and you multiply it with Z conjugate, you can see x plus iy into x minus iy will be in the form a plus b into a minus b. So you can apply that identity and very easily you will get that Z into Z conjugate, right, will in fact be equal to x square plus y square, which is in fact the square of its modulus, right? So mod Z the whole square, right? So those are some of the basics that that get used in coordinate that get used in complex numbers, and I hope that you guys remember all of this. Okay, moving on. Let me quickly check if the exercise has been assigned there. No, it hasn't. I think there's some technical issue at the back end. I've asked for them to look this up. In the meanwhile, right? In the meanwhile, what I will do is I'm going to start giving you some questions on complex numbers. Right? I'm going to start from the exercise. So don't worry, the exercise will reach you in very, very short time. In the meanwhile, here's the first question, right? If A and B are real numbers between 0 and 1, right? It's known that A and B are real numbers between 0 and 1, and the points Z1, which is A plus I, Z2, which is 1 plus B into I, and Z3, which is 0, they form an equilateral triangle, right? This is given to you, right? So A and B are real values, real numbers that have values between 0 and 1, and Z1, Z2, and Z3 are three complex numbers which form an equilateral triangle in the Argand plane, right? Then we'll find the relationship between A and B. Which of these basically is true? And the conditions given to you are A is equal to B is equal to 2 minus root 3. Second option is A is equal to 2 minus root 3, B is equal to root 3 minus 1. Option C is A is equal to root 3 minus 1, B is equal to 2 root 3. And option D says none of these is true, right? Can you guys work this out? Tell me what you get. Which of the following conditions will in fact be true? Which of the following conditions will actually spell out the correct relationship? Yeah, so what's the condition I'm going to use here? It says they form an equilateral triangle. Let me take away the option choices for just a minute and we can try solving this question, right? Zyadatar complex numbers, there are two approaches that we usually use when you're dealing with complex numbers. You're either going to deal with the real part, imaginary part, and its relationship, vis-a-vis the modulus or argument, right? Or the second approach you take is you start thinking like it's coordinate geometry, because there's the real part, there's the imaginary part, and you can think like you would do in a coordinate geometry question, right? And this exercise is a mix of questions of both, using both approaches. Like for example, here, the moment it says equilateral triangle, I know equilateral triangle has equal sides, right? First thing that comes to your mind is that in equilateral triangle, all the sides would be equal, right? So if Z1, Z2, Z3 are equal, then I can equate, Z1 minus distance between, let's say, let me explain that to you. Let's say this is point A, this is point B, and this is point C, right? So you have 3 points. What are these 3 points? You can think of them as coordinates as A, 1, 1, B, and 0, 0, the origin, right? So you have these 3 points on the argand plane, and what you want is you want to form an equilateral. You want them to form an equilateral triangle, right? So coordinate geometry ka logic use kare, when are 3 points? When will 3 vertices form an equilateral triangle? If they are equidistant. So the condition that I'm going to use is that the sides must be equal. So I'm going to say AB is equal to BC is equal to CA, right? I don't know if I'll need to use all 3 distances, but for sure distance formula or the distance approach is what we will use here. So what is the distance between point A and B? Let's use the distance formula, root of x2 minus x1. So I can say this is going to be 1 minus A the whole square plus B minus 1 the whole square, right? This is going to be AB, the distance of point A from point B. What is the distance of point B from point C? BC. Distance again will be x2 minus x1 the whole square. So that's 1 minus 0, 1 square, plus B minus 0, that's B square. And the third distance AC will be equal to root of A minus 0 the whole square, that's A square, plus 1 minus 0 the whole square, that's 1 square, right? So if you apply distance formula, then this is the relationship that you'll get, right? And obviously, I'm getting 3, you can equate them in pairs. That will give you 2 equations in A and B. And somehow you need to solve and get the values of A and B, right? So after this, the moment you apply the distance rule, it becomes a straightforward question. What do I do? Square all of this, right? Squaring this, I'll get A minus 1 whole square plus B minus 1 whole square, right, is equal to B square plus 1, which is also equal to A square plus 1, right? So if I equate these two, right? If I equate these two, then I'll get A square equal to B square, which means A is equal to plus or minus the square root of B square, which is B, right? So first condition I get is that A is either equal to B or A will be negative of B. Let's take that and substitute it in this equation. Equate these two now, right? If I equate these two and substitute, right, what I will do is I will split this into 2 cases. One case I'll put A is equal to B, and the other case I'll need to put A is equal to minus B, right? So instead what I can do is I can also substitute A square equal to B square, right? Or in fact, wherever I get B square, I can substitute that with A square, right? That's also something you could do, right? But remember that in fact A is equal to plus or minus of B. We have a condition that the problem gave us, right? It said that both A and B must lie between 0 and 1, which means if B is positive, A must also be positive, which means A can never be negative of B, which means in this case I'll say A must be equal to B. Negative is not allowed, right? So we can straight away say A cannot be the negative, A has to be the positive value because both values are positive, right? So both will be of the same sign. So substituting that here, my equation becomes A minus 1 whole square. Let me in fact expand that. That gives me A square minus 2A plus 1 plus, again, B is equal to A means this is also minus 1 whole square. A square minus 2A plus 1 would then be equal to B square plus 1. I can say that is A square plus 1, right? Because A and B are equal. In fact, the moment I get A equal to B and you scan your option choices, right, you can see option A might be correct, but option B and C are both incorrect because A and B are not equal, right? So I'm either going to 50-50 chance to abhi se ho gaya, ya to A correct hai ya option D will be correct, right? But let me solve it nonetheless, right? So if I do this, 1A square will get cancelled out. My equation becomes A square minus 4A, and the 1 also goes away, plus 1 is equal to 0, right? So using the discriminant method, A will be minus B, that's 4, plus minus square root of B square, 16 minus 4 is 12 upon 2A, right? So if you simplify this, what do you get? You get 2 plus minus root 3. I get b is equal to 2 plus minus root 3. Obviously, the plus will not be allowed because then it will be more than 2. Right? So you can't allow the plus. So you'll say 2 minus root 3 is the only option that is the correct one. Which one is that? That choice agrees with option A. That choice agrees with option A. So the answer to the first question here is option A. Right? This is question 1 from the exercise. If you guys don't have access to the exercise, click on the link below and you will get the exercise on complex numbers. Remember, I am not going to consider bilkul basic level of questions where I give you a problem, ask you for modulus, ask you for argument. I think this is something that you would have already studied in class 11th, right? And so I don't see the need to do that all over again. So we'll try and look at a mix of slightly harder problems. Let's discuss question number 2, right? And those of you who can't see it in your accounts, let me write that up, pull that up on the board right now. Okay, this one says find the real part of z is equal to 1 upon 1 plus 1 minus cos theta, plus I sin theta. Find the real part of this complex number is the next question. Find the real part of z is equal to 1 upon 1 minus cos theta plus I sin theta, right? Find the real part. The part without the iota, right? It's fairly obvious what the next step is going to be, guys. Okay, I'm going to wait for you guys to, at least some of you, to get to the end of this question. Right, jaldi karte hain. There are a few challenging questions lined up in the exercise today. So make sure that you get these first few easy questions done quickly. Right? How do I work with this? I obviously need to rationalize it. Right? I obviously need to rationalize this number first, because in the denominator I want this to be free of iota. So let's rationalize this by multiplying, this with its conjugate. So I'll multiply with its conjugate, which will be 1 minus cos theta minus I sin theta, and also divide by the same thing. So this becomes a plus b. Think of this as a and this as b. A plus b, a minus b will be a square. That's 1 minus cos theta the whole square minus b, a square minus b square minus I sin theta the whole square will be minus sin square theta. Yeah, because the square of iota is minus 1. So I square will become minus 1 and sin square theta. And numerator remains the same. 1 minus cos theta minus I sin theta, right? So clearly the question asks me for the real part, right? So the next thing I need to do is I need to quickly simplify this and then just, forget the imaginary part of it. Just report what I get in the real part, right? So what is the real part? The real part will then be, the real part of z will then be 1 minus cos theta divided by, what is the denominator? 1 minus cos theta, the whole square. Let me in fact open this. 1 plus cos square theta minus 2 cos theta plus sin square theta. And obviously sin square plus cos square becomes 1, and 1 plus 1 becomes 2. So this becomes 2 into 1 minus cos theta, and the numerator is also 1 minus cos theta. So I can comfortably cancel this, and this becomes 1 by 2. Ideally, a note of caution at this point. Remember, when you're cancelling out something in the numerator and denominator, you must make sure that it's not equal to 0, right? Whatever you're cancelling out must never be, possibly equal to 0, right? When will cos theta be equal to 1? When theta is 0 or 2 pi or one of those values, right? Infinite such a set of values theta for which that can happen. But ideally the question here should have stated that cos theta is not equal to 1 or theta is not equal to 2n pi. That's a condition that usually would be given. But in this case, all options are, none of them is none of these or does not exist. So I don't think that is going to be a bother if this, this is the form in which it comes in the exam. Yeah, Aryan, that's the thing. I think you still need to, I don't know for what. आप एक काम करो, Aryan, just log out, close the browser, refresh your desktop, and then open the browser again, log in, and you will be able to access the exercise. I think your browser is not letting go of the older version of the file, right? So just try and do that. In the meanwhile, we're going to start question number 3. Let me pull that up for you. Right? If x plus iy to the power of 1 by 3 is equal to a plus ib, then find the value of x by a plus y by b. This is the question. If x plus iy raised to the power 1 by 3, I hope you guys know when the power is a fraction, it's actually a cube root, right? So 1 by 3 means cube root. 1 by 4 means fourth root. So this is the cube root of this complex number is equal to this other complex number. Then can you find the value of this expression? It's a very simple question. I mean, it's fairly obvious what the next step is going to be, right? So I'm going to wait for you guys to get this done now. Yeah, thanks, Aryan. Great. I hope everybody is now able to access the exercise. For those of you who are joining us now, please register with us in the link given in the description, and you should be able to access these class exercises. And also, registration also gets you all the IPM mocks for free. Make sure that you avail of that offer. Right. How many of you got the answer to this question? Arushi says B. How many of you agree with her? Okay. Right. So obviously, to solve this question, what you do is you cube it. है ना, cube कर देंगे. If 1 by 3 power में रहेगा, obviously it's going to be hard to solve. So I simply cube both sides. So this becomes x plus iy. And on the other hand, if you cube a plus iota b, right? This is like, you don't need to worry about anything. You just need to remember the formula for a plus b whole cube. A plus b whole cube, and expanded becomes a cube plus b cube plus 3a square b plus 3a b square, right? This is the way you should know the formula. So then just open it. This is a cube. Here I'll get I cube, right? I'm going to get I cube into b cube, right? This is 3a iota into 3a square b plus, in this case I'm going to get 3ab into ab square into iota square. Clearly iota square is -1, so this becomes minus 3ab square. Iota remains into 3ab, sorry, a square b. Iota cube, I square is equal to -1. So I cube, multiply both sides with with iota to get I cube as minus I. So this becomes minus IB cube, and this is A cube, right? And if this is x plus IY, clearly I can equate the real parts and the imaginary parts, which means x will now be the real part, a combination of these two terms, right? So x would be A cube minus 3ab square, and y will be everything, in the next two terms, exclude the iota. So y will be 3a square b minus b cube. And the question asked me for x upon a. So clearly from here, I'll get x upon a. Divide this by a. X upon a becomes what? A cube by a is a square. And 3ab square upon a will be minus 3b square. And similarly, y upon b. Divide this by b. I'll get 3a square minus b square. Right? And then the question asked me for their sum. So if you add, x by a plus y by b will then become, what happens? A square plus 3a square is 4a square minus 4b square. So 4a square minus b square, right? 4 times a square minus b square. That's option A. Yeah. Okay. Quite a few of you guys managed to figure this out, right? Simple question hai, kuch nahi hai. We just need to apply, either the distance formula or cube or rationalize and then equate real part, imaginary part, on the both ends, right? Most common question type from complex numbers. Ye question bilkul chhodne layak nahi hai. This is, this is like a, short question. You should practice. You should know as much complex numbers to be able to get this one right. Great. Let's try the next one. Question number 4. Right? Find the smallest value of the integer n if the given expression is true. If 1 plus I upon 1 minus I is equal, raised to the power n is equal to 1. Then which power, what is the value of n which makes this, sorry, what is the smallest value of n which makes this true? Okay. I have a very quick answer from Anshuman. My suggestion will be, Anshuman, maybe you want to check your answer just again. Did you use the option choices to try this out? Because then, if you try to use option choices here, option D hone ke karan, thoda sa dangerous hai. Maybe it works out for 8, but how do you know it doesn't work for 6 or for 4 or for 2? Is it? Okay. Hardik seems to think it is 2, and so does Siddhant. Detect कर लिया आपने message को. Right, I have 1 plus I divided by 1 minus I raised to the power n is equal to 1. Right, and the question says, what is the smallest value of n for which this holds true? Right, अच्छा, तो इसका most obvious thing देखो, जब भी whenever you're dealing with complex numbers which have a denominator and the denominator is a complex number, try and rationalize it, right? Try and make it a real number. So what do? Inside the bracket itself, I'll say 1 plus I by 1 minus I was already there. I multiply this by 1 plus I again. and divided by the same, right? So that nothing changes. And now a plus b, a minus b will be a square 1 minus b square, and iota square is indeed minus 1, right? So this is what I get. Numerator is 1 plus iota the whole square, right? And this raised to the power n gives me is indeed equal to 1, right? And then what? Obviously my denominator is 2. 1 plus 1, 2. So what I get is, and let's, open the numerator up. A square, b square is iota square minus 1 plus 2ab, 2i raised to the power n is equal to 1. So 1 and minus 1 will cancel out. 2 and 2 will get cancelled out. I get I to the power n is equal to 1. So which value of in? Which power of iota becomes 1, right? I know I square, I is equal to square root of minus 1. So I square will be equal to minus 1. So obviously n can't be 2. And if I square this again, I power 4 will become equal to plus 1. So the smallest value of n, which makes this true, will be the fourth power, will be n is equal to 4. I hope you guys are able to figure it out. Not a very hard question again, but one that uses, your understanding of iota and rationalization. You can see, the first set of basic problems will always use rationalization, identity ka usage, or maybe I use a little bit of coordinate geometry in it. Yeah, distance formula and whatnot. Right? So do anticipate this level of questions, right? Rationalizing and calculating the modulus, right? Very, very common. Any questions so far? Yeah, are we clear with this thus far? Okay, let's move on, right? Okay, let's pick up something a little more challenging now. Okay, let's look at fifth. Look at question number 5. Even the wording of the question tells you thoda sa kuch alag ho raha hai is question mein, right? Z is a complex number of unit modulus, which means mod z is 1, and it has an argument of theta. Then what is the argument of 1 plus z upon 1 plus z conjugate? What is the argument of 1 plus z upon 1 plus z, the conjugate? Right? If I want to put down the conditions given here, it says mod z is 1. The argument of z is given to me as theta. And the question says find the argument of mod of 1 plus z upon 1 plus z conjugate. Let's calculate this. So how to proceed? How to work with this problem? No, z is not iota. Doesn't say that. Unless that's something that you calculated in the question, that z is equal to iota. It doesn't say that anywhere. No. Because if z were iota, then argument would be pi by 2, right? That's not something the question says. Right? Basically, mod z equal to 1 basically is a point which, anyway, I'll come and explain that to you in a bit. What is unit modulus, right? Unit modulus means that it's a point It's a point which is 1 unit away from the origin on the argent plane. देखो मैंने आपको बताया था ना, x, y, the complex number z, which is represented as the point x, y on the argent plane. What is z? Z is equal to x plus iy. So this point is complex number z can be plotted as a point in the argent plane, where this is the real part of z and this is the imaginary part of z. You can think of this as x and y axis, right? So if I plot this, then this is the point, right? And what is modulus? The distance from origin. This is called the modulus of z. So mod z will always be the distance of a point from the origin. So mod z, if modulus of z is 1, it means that that point is 1 unit away from the center. But does it have to be on the y-axis or the x-axis? No. It can be 1 unit anywhere. In fact, I can draw an entire circle with radius 1 about the origin. All points on the circle will have a modulus of 1. Is it not? So the complex number z can lie anywhere on this. Depending on where it lies, where it lies will actually depend on theta. If theta is 0, this is that point. If theta is 90, this is the point. If theta is, it can also be any of these other infinite points on the circle, right? That's what, modulus and argument imply, right? Where do you plot it on so the coordinate geometry, aspect of complex numbers is very unique. It's a very useful way of approaching questions also, right? So we will get into this in a lot more depth in just a while, right? But let's get these questions done first, right? This question is itna complicated nahi hai. All I need to do is, okay, for example, the moment I know mod z is equal to 1 और यहाँ पे z conjugate आ रहा है, right? So we'll think, okay, what about z into z conjugate? What do I know? This is equal to mod z ka square, right? But if mod z is 1, then this will be equal to 1, which means z conjugate will be equal to 1 by z, right? And so let's work with this, right? What is 1 plus z upon 1 plus z conjugate? This will be 1 plus z upon 1 plus 1 by z. So what will this simplify into? 1 plus z upon z plus 1 into z. So ये तो कट गया. 1 plus z and z plus 1 are the same, which means I'll end up getting this as equal to z. So what expression I had, the complex number that I had is nothing but the same complex number z, which means argument will be what is given over here. Option, answer will be theta, which is there in which choice? Question number 5. Theta is option C. Absolutely. And I think one of you guys marked it. Some of you, yes, Arushi indeed right. Arushi, Kriti, yeah, all of you are indeed correct, right? This question has an argument which is equal to theta, right? Let me repeat. Dekho, the question gave me mod z is equal to 1, right? And it said calculate the argument of this expression, right? So जैसे मैं इस expression को देखूंगा, I know that this is 1 plus z upon 1 plus z conjugate. The moment I see conjugate, I'll think conjugate का एक formula होता है z into z conjugate is equal to mod z square. And since mod z is 1, question says unit modulus, means unit is 1, which is the modulus. So mod z is equal to 1 means this becomes 1 square equal to 1. So z into z conjugate is 1, which means I can write z conjugate as 1 upon z. इसको उठा करके इसमें substitute कर दो, and if you simplify, you'll end up getting z. So the question asks me for the argument of z. The argument of z is given in the question, theta. That's your answer. Does that make sense to everybody? All of you guys listening in live, I hope it makes sense to you. You just need to rearrange this expression, rework this expression on the basis of this z conjugate is equal to 1, right? Usually z conjugate will be mod z the square. Yeah, think about it. X plus iy, this is z, and z conjugate is x minus iy. So what happens to the product if you multiply? A plus b into a minus b is a square minus iy the whole square. So that will be minus y square. So you get x square plus y square, right? And which is indeed the square of the modulus, right? So the formula is z conjugate is equal to mod z square. And I simply use it to substitute the value of mod z z conjugate as 1 upon z. इसमें उठा करके expression में डाल दो, and numerator denominator will get cancelled out. You'll be left with only z. So if this expression is z, then the question asks me to calculate its argument. So I want argument of z. Argument of z is theta. That's it. ये सब जरूरत ही नहीं है. All of this, talk about, argand plane and all is not needed in this problem at least. Does that make sense to you, Siddharth? यार अब तो लिटिल बिट से आगे बढ़ जाओ. अब तो मैंने डिटेल में बता दिया आपको. Yeah. All right. Let's move on. This was question number 5. Right. Let's look at a few other questions. Okay. This one, sixth one says, let Z and W be two non-zero complex numbers. अच्छा, दोनों complex numbers are non-zero हैं, which means at least the real part or the imaginary part should not be zero. Both can't be zero. Okay. Such that mod Z is equal to mod W, and argument of Z plus argument of W is equal to pi. Right? What this means is कि देखो याद रखो, किसी भी complex number Z which can be written as x plus iy, we know it has a mod Z which is x square plus y square under the root, and it also has an argument which is equal to tan inverse y by x. Right? मतलब एक वैल्यू होगा और एक थीटा होगा, right, which will exist for every complex number, right? So basically the mod z tells you कि भाई origin से कितना दूर जाएं, और थीटा क्या बताता है किस एंगल पे जाएं. If this is the argand plane, then theta tell me go at this angle for this much distance, go at this angle for this far. That's where the complex number is, right? That's the meaning of modulus and argument. I hope that you guys are able to get a tangible understanding of what modulus and argument is, right? So here the question says, though as a number hai, Z and W, both are complex numbers which are not zero, and they have equal modulus, and the sum of their arguments is pi, right? Theta 1 plus theta 2, you can think, right? If the angles are theta 1 and theta 2, then theta 1 plus theta 2 is equal to pi. Theta 1 plus theta 2 is equal to pi, right? So then the question says, find the value of Z in terms of W, right? Is Z equal to W? Is Z equal to minus W? Is it equal to W the conjugate or negative of W conjugate, right? Which one of these equals Z? That's the problem as it's stated, right? So how should I proceed, right? Now right. So how do I use this? How do I solve this particular question, right? So remember class ke starting pe I told you that a complex number, besides being represented in its real and complex form, there's also that theta wala form, right? Remember the Euler form. So here that's what I'm going to do, right? I'm going to say, okay, Z is equal to, let's say it has a modulus of A cos theta plus I sin theta, right? I know this is Z, right? So if this is the argument, theta is basically what I've assumed is that argument of Z is equal to theta. So if this is theta, what is the argument of W? Clearly, if you take this on the other side, it will be pi minus theta, correct? So if Z is equal to cos theta plus I sin theta, what will W be written as? Can you try and write it yourself? Uska modulus is exactly the same. Both of them I've assumed as A, which means this remains A. But now instead of cos theta, I'll say cos pi minus theta plus I into sin pi minus theta. Right? Cos pi minus theta iota into sin pi minus theta. Right? Sorry, not x, theta. Right? And what's the value of cos pi minus theta? What's the value of cos pi minus theta? It turns out that that's minus cos theta. And what is the value of sin pi minus theta? It's equal to sin theta. Right? So minus cos theta plus I sin theta aa jayega as W. So what is the relationship now between W and A? Is W equal to Z? No. You can see minus aa gaya. In fact, if I take the minus sign common, what will this become? Minus A into cos theta minus I sin theta. So you can see that if I take the minus sign on this side, minus w agar मैं लिखूं, this will be equal to a into cos theta minus I sin theta. Can you see something happening? You know, if you look at the just the right hand side, both of them have the same modulus, and cos theta यहाँ पे negative हो गया है, cos theta minus I sin theta instead of cos theta plus I sin theta. It turns out that this expression is actually the conjugate of the previous expression that we had. Right? This is the conjugate of this, or alternatively, this is the conjugate of that. Right? So then I can say minus w is equal to z conjugate, or I can say z will be negative of the conjugate of w. Both of these are equally true. Right? Both of these are equally true. So what should I mark? What should I mark here? I have option A as z equal to w. That's not true. Minus w, not true, because it'll be either minus w conjugate. Okay, since the question asks me for z, then I'll need to mark minus w conjugate. That's option D. That's option D, right? I hope you guys are able to figure this out, right? ज़्यादा दिमाग नहीं लगाना है यहाँ पे, जैसे sum of arguments equal to pi दिया है. It's a very, it's a very complicated way of saying, अच्छा, theta 1 plus theta 2 is equal to pi, which means theta 2 will be equal to pi minus theta 1, right? Which means sin theta 2 will be equal to sin theta 1, but cos theta 2 will actually be equal to minus cos theta 1, right? It turns out that trigonometry works like this, right? And I hope you guys remember that part of trigonometry, right? If it's an even multiple of pi by 2 and you're doing cos n pi by 2 minus theta, then even multiple means the trigonometric sign remains exactly the same, and the sign depends on which quadrant it lies in, right? And this one will lie in the second quadrant, and the second quadrant sign is still positive, but the other two are negative, right? So cos theta would be negative. Does that make sense to everybody here? Does that make sense to everybody? Clear to everybody? अभी तक, by the way, मैंने tough question introduce नहीं किया है. These are all still considered of basic aptitude level, right? And this is the level that you definitely must attempt. Yeah. Okay. Great. You guys are doing great then. Okay. Let's try question number 8. Let's try question number 8. From the exercise, try question number 8. It asks you for the condition to construct or make a parallelogram. A little bit of knowledge about what a parallelogram is will actually help. I hope you guys remember what a parallelogram is. Points Z1, Z2, Z3 and Z4. I think Z4 missing है. Please add कर लीजिए. Z1, Z2, Z3 and Z4. In the complex plane are vertices of a parallelogram if taken in order. Only if, yes, Z4 is missing in the question. That's right. The 4 points Z1, Z2, Z3, Z4, complex numbers on the Argand plane will make a parallelogram when considered in a sequence only if what? Right? So this is where, hint, this is where coordinate geometry will help me. Okay, some of you have already started to figure it out. I'm glad. देखो इस क्वेश्चन को कैसे करेंगे. एक्चुअली बहुत इजी क्वेश्चन है. इट्स अ वेरी स्ट्रेट फॉरवर्ड क्वेश्चन, राइट? बिकॉज ऑल आई नीड टू डू इज आई नीड टू थिंक ऑफ इट लाइक कोऑर्डिनेट ज्योमेट्री, राइट? क्या दिया हुआ है? ओके, Z1, Z2, Z3 and Z4, right? Are, you can think of these as 4 points on the plane: Z1, Z2, Z3 and Z4, right? Remember, coordinate geometry means that each point will have xi, x4, y4. This will be x3, y3, and this is like x2, y2. This is going to be like x1, y1, right? Now, if this is a parallelogram, I need to use some concept of geometry, obviously. And so the concept here is that in a parallelogram, opposite sides are equal, right? That's a condition I can use. I could say the distance between Z1 and Z2 is equal to the distance between Z2 and Z3, right? It's one, that's one condition I can surely say. But then opposite sides are equal also in a rectangle, also in other kind of, trapezium also it might be true, right? That opposite sides are equal, right? So actually the foolproof condition is that in a parallelogram, if you join the two diagonals, then they bisect each other, right? That the diagonals bisect each other. This is the condition. Diagonals bisect each other. So the easiest way is to think, okay, this point of intersection of the diagonals will be where Z1 and Z4 will be the midpoint of Z1 and Z4, right? If you consider Z2 and Z4. And this point will also be the midpoint of Z1 and Z3. So what you can say is the midpoint of, and let me name these, A, B, C, D, right? So the midpoint of AC must be equal to the midpoint of BD. What is the midpoint of AC? AC midpoint will be Z1 plus Z3 by 2. I can write it this way because it will automatically mean x1 plus x3 by 2 will be the real part and y1 plus y3 by 2 will be the imaginary part. Similarly, equal to Z2 plus Z4 upon 2. Right? And obviously, when I equate them, the divided by 2 will get cancelled out. So the condition must be Z1 plus Z3 is equal to Z2 plus Z4. That's, I think, option B, right? As some of you are pointing out. It's not the most obvious of things, right? But agar मैं option scan करूं, right? The first three options don't have squares, don't have square roots. It surely seems like you don't need to do too much of mehnat, right? Other conditions you could have also put AB equal to CD and AC is equal to BD. You could have done these, right? But then they will involve distance formula ka involvement ho jayega, and that will include a square root. So if I look at the option choices, without square root, if I want to try something out, then it will be, in this manner. Right? Okay, try the 10th one. Try try the 9th one. Try the 9th one. Same logic, similar thought. Thought process similar hona chahiye. Again, here 3 points Z1, Z2 and Z3 represent the vertices of an equilateral triangle. And there's some condition given over there. Mod Z1 is equal to mod Z2 is equal to mod Z3. Then, which of these is true? Okay. Anshuman says A, so that is Z1 plus Z2 plus Z3 equals 0. Again, most of these, next few following questions will keep borrowing from coordinate geometry. There are 3 points Z1 and Z2 and Z3. Okay? Think of these 3 points. A, B, C are 3 points. A represents Z1, B represents Z2, C represents Z3. And ABC is an equilateral triangle. Matlab AB equal to BC equal to CA hoga, right? But again, I can see if I do AB equal to BC, then I'll have to do Z1 minus Z2 under the root. Z1 square minus x2 minus x1 whole square plus y2 minus y1 whole square under the root, right? That will be the distance formula that you're going to have to use, right? But options में तो directly Z1, Z2, Z3 दिया हुआ है, so that doesn't seem to make much sense, right? But there is one more piece of information given here, right? It says mod of Z1 is equal to mod of Z2 is equal to mod of Z3 equal to 1. Right? ये दिया हुआ है ना, mod Z1 equal to mod Z2. Yes. No, equal to 1 नहीं दिया हुआ, mod Z1 is equal to mod Z2 is equal to mod Z3, right? अब ये mod Z1 क्या हुआ? Right? Let's go back, right? What did I tell you? I told you that any point Z will have an x coordinate and a y coordinate, and modulus of this point will be the distance from the origin. So this will be mod Z, no? Right? So mod Z1 will be कि OA का A का distance origin से क्या है? So mod Z1 will be equal to OA, mod Z2 will be OB, and mod Z3 will be OC. So what the question gives you, if you understand a little bit of coordinate geometry, then the question gives you the condition कि A, B और C तीनों का modulus अगर same है, then all three of them are equidistant from the center. Remember sometime back I told you unit modulus का क्या मतलब है? It's 1 unit away from the origin, which means it can lie on a circle which is 1 unit का radius. उस सर्कल पे भी कहीं भी हो सकता है. तो उस सर्कल के 3 पॉइंट्स ऐसे चूज किए हमने जो इक्विलैटरल ट्रायंगल बनाते हैं, राइट? And now the question says, okay, what links Z1, Z2 and Z3? Now, without using any more coordinate geometry, let's think about a triangle, right? If this is a triangle A, B, C, and you have a point O, which is equidistant from all the 3 vertices, OA, OB and OC. तो ये O point हुआ क्या, right? Ab, I know that you guys haven't done itna geometry, but it turns out that O will be the center of this circle called the circumcircle, right? But in an equilateral triangle, this point is also the median. And that is the condition that we use in this question. ये थोड़ा सा tough question हो गया इस वजह से, right? Because you need to figure out that O, the center, the origin of the argand plane, since it is equidistant from A, B and C, that point will also be the centroid. What is centroid? Where the medians interact. Or, yeah. So the condition is in an equilateral triangle, centroid is equal to circumcenter, even the incenter, right? जरूरत नहीं है incenter की, but centroid is also equal to the circumcenter, right? What is centroid? Centroid is where the medians intersect. What is circumcenter? Where the perpendicular bisectors intersect. What is incenter? Where the angle bisectors intersect. Right? ये concept geometry के बहुत कम use होते हैं, which is why we haven't covered this in class. बहुत कम use होता है. ऐसे एक outlier question है जहाँ पे use होगा, right? But that's what we are using here. That in an equilateral triangle, ये जो medians जहाँ intersect करेंगे और perpendicular जहाँ intersect करेंगे वो same point होगा. तो मतलब ये point centroid हो गया, right? और अब हम coordinate geometry use करेंगे, right? For in coordinate geometry, there is a direct formula for centroid. Centroid is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Basically, centroid is where all the three, can be averaged out. So here, if the origin is the centroid, if origin is the centroid, then origin should also be equal to Z1 plus Z2 plus Z3 by 3, right? Since O is the origin, which is where OA, OB and OC come. O is the origin. तो O अगर origin है, तो इन तीनों का जो median का formula होगा Z1 plus Z2 plus Z3 upon 3, that should be equal to origin. And what is origin? 0. Right? So there you go. If you equate it, you'll get option A as the right answer, right? Z1 plus Z2 plus Z3 equal to 0. That's the answer to this question, right? तो आपको दिखेगा कि in a lot of questions, it actually helps if you take a coordinate geometry perspective. Yeah, try the next one. Try question number 10. अगर आपको ये क्वेश्चन 9th समझ में आ गया है तो 10th actually depends on the 9th slightly. The number of complex numbers Z such that Z minus 1 in modulus is equal to Z plus 1 in modulus is equal to Z minus I in the modulus. And all three moduli are equal. Right? Mod Z minus 1 is equal to mod Z plus 1 is equal to mod Z minus I. And this is the way the problem is presented. Z minus 1 is equal to, mod Z minus 1 is equal to mod Z plus 1 is equal to, all three are equal. Then how many numbers Z will be of this form? How many numbers will be in this which satisfy this equation? Yeah, I'll give you guys 1 minute to think about this, and then I'll tell you the answer. Answer kafi. And the trick is to figure out what does this mean. Right? If you remember this, पिछले question में we had mod Z1 is equal to mod Z2 is equal to mod Z3. And we said that when you have nothing inside the modulus, it's the distance of the point from origin. So what will this be? What will this be? This will be, right? Think of this as, let's say, Z minus Z1 in modulus is equal to Z minus Z2 in modulus is equal to Z minus Z3 in modulus, right? If you think about it this way, then basically what it says that there are 3 points, A represented by Z1, B represented by Z2 and C represented by Z3. मतलब कोऑर्डिनेट प्लेन में 3 पॉइंट है ऐसे A, B और C, right? A, B and C are 3 some points on the plane such that Z minus Z1. Now what is Z minus Z1? Right? Z minus Z1, the first one inside modulus. याद रखो, if you do Z minus 0, you'll get Z, mod Z, and mod Z is distance from origin. So mod of Z minus Z1 is actually the distance of Z from Z1. Similarly, this is the distance of Z from Z2. This is the distance of Z from Z3. अगर मैं Z minus 1 कर रहा हूं तो मतलब इसमें पॉइंट क्या है? Z1 कौन सा पॉइंट है? माइनस वॉट 1. दिस इज द पॉइंट 1,0. तो मतलब 1, if this is A, then we are trying to say that a point Z, the distance of that point Z from this point A will be the distance Z minus Z1. Right? So basically, this equation actually translates into PA is equal to PB is equal to PC, where P is the point Z. P represents the point. There are 4 points basically, right? 3 points are Z1, Z2 and Z3, and the 4th point is Z, which comes in all 3, right? So if that is the point P, then what will PA be? The distance of P from A will be mod of Z minus Z1. The distance PB will be mod of Z minus Z2. The distance PC will be mod of Z minus Z3. And the question says all 3 are equal, which basically means PA is equal to PB is equal to PC. Imagine करो, एक पॉइंट ऐसा है P जिसका डिस्टेंस A से, B से और C से equidistant है, right? So then what kind of a triangle will this be? In fact, the question says how many such points exist. So you don't care about the triangle, but then you'll say, अच्छा ये कैसा पॉइंट हुआ? Equidistant from all 3. Won't this be a unique point? अभी हमने बोला a point which is equidistant from all 3 means that P is the circumcenter. Circumcenter का क्या मतलब हुआ? It is the center of the circle which circumscribes this triangle. तो अगर एक सर्कल बनेगा तो यूनिक सर्कल बनता है. There can only be one circle which encloses all the 3 points of a triangle. So if there is a unique circle, then there must be a unique point. And so this point P will also be a unique one. Does that make sense? Is that point clear to everybody? Yeah, Ishika, we will be posting logical reasoning videos as well, right? So keep watching our channel for more updates. I think next week or so is when LR videos will also start coming up. For now, LR topics are being done in a different course called LSAT, also available on our channel. Right, let me repeat this, right? देखो इसमें coordinate geometry का logic थोड़ा सा समझना है आप लोगों को, right? So let me repeat this all over again, right? And in fact, then we'll come back to this, right? Coordinate geometry बोलता है Z, X, Y, right? Or Z, which is equal to X plus IY, basically is a point. Correct? So I can plot this here. I can say, let's say this is the point P, which has an X coordinate. It also has a Y coordinate. So it will be a point P, right? If P is representing this point, then OP will be mod Z. Does that make sense? This is origin O. So distance O, distance of the point P from origin will be mod Z. तो अगर मैं directly Z पे modulus लगा लूं, then I should identify that as, okay, the problem means that mod Z means the problem means the distance from the origin. If instead of mod Z, I put mod Z minus Z1, then it won't be distance from, remember OP means distance of P from O. What is O? Origin. So OP की जगह ये हो जाएगा, let's say, think of it as QP, let's say. Basically Z minus Z1 will be distance of this point P from another point Q. तो अगर मेरे पास दो पॉइंट है उस प्लेन पे, एक है z1 एक है z2, राइट, तो ये होगा मॉड z1, ये होगा मॉड z2, बट ये जो डिस्टेंस होगा ना pq, this will be mod z minus z1. In fact, in this case, z1 minus z2. If this is z1 and this is z2, then distance between these 2 points will be mod z1 minus z2, right? So ever if you have inside a modulus, if you have something minus something in the modulus, right, z minus z1 in the modulus, you'll know a distance of one point from another point. Not distance of one point from origin, but rather one point from another point. ठीक है, अब ठीक है, now this we've understood. Now let's come back to the question, right? Remember this, OP will be distance of mod z, whereas z minus z1 will be distance of one point from another. Now question में condition क्या दी हुई है? Question gives you mod z minus z1 is equal to mod z minus z2 is equal to mod z minus z3, right? So I'll think there is z, there's z1, there's z2, and there's z3. All of these will be points. So let me name the points. P, A, B, and C are the points. P represents Z, A represents the point Z1, B represents the complex number Z2, and C represents the complex number Z3. Correct? तो ये Z minus Z1 क्या होगा? अगर Z minus Z1 is distance of Z from Z1, then Z minus Z1 will be the distance of P from A, which means PA is equal to Z minus Z2. Z minus Z2 will be the distance PB. Z minus Z3. P from Z minus Z3 corresponds to the distance PC. So what this means is that the distance of the point P from all the three vertices of this on the plane, forget vertices, I can think, implies P is a point equidistant from 3 points. मतलब एक ऐसा पॉइंट है z जो 3 गिवन पॉइंट्स ऑन द प्लेन से इक्विडिस्टेंट है. नाउ इफ इट्स इक्विडिस्टेंट, इट इमीडिएटली मींस p इज द circumcenter, right? I have already explained what the circumcenter is. It's the center of the circle that contains the encloses the triangle. Circumcenter of triangle ABC, है ना? बेसिकली तीन ऐसे कहीं पे भी प्लेन में तीन ऐसे पॉइंट्स हैं A, B और C, और मुझे ऐसा एक पॉइंट मिल गया P such that PA is equal to PB is equal to PC. ये तीनों लेंथ इक्वल है, तो अगर मैं इसको सेंटर रख के इसको रेडियस ले लूं तो आई कैन वेरी इजीली मेक अ सर्कल लाइक दिस, नो? Which means that circle is called the circumcircle and that point will be the center of that circle. Now the idea here is, ये सब क्यों यूज कर रहे हैं? क्योंकि बनाना सॉल्व वॉल्व कुछ नहीं करना. जैसे ही आपको सर्कमसेंटर समझ में आ जाए, सर्कमसर्कल समझ में आ जाए, then you need to ask yourself, अच्छा 3 पॉइंट्स के लिए कितने सर्कल बनेंगे? एक ही सर्कल बनेगा. There can only be one circle which can enclose 3 points on a plane, and so there will be only one center, and Z is that center, P is that center, sorry, and P represents Z. So how many points Z can be there? How many values of Z can be there? Only the one. Yeah, does that now make sense? Does that make sense to you? मैंने आपको बोला था कोऑर्डिनेट ज्योमेट्री आते थोड़ा सा हार्ड होना शुरू हो जाएगा, बट देयर आर ओनली 2-3 कॉन्सेप्ट्स इन कोऑर्डिनेट ज्योमेट्री. इनफैक्ट यही दोनों कॉन्सेप्ट यूज करने. जहां पे भी मॉड z आ गया वहां मुझे पता है डिस्टेंस फ्रॉम ऑरिजिन हो गया. जहां पे मॉड z माइनस z1 हो गया, दैट विल बी डिस्टेंस ऑफ वन पॉइंट फ्रॉम द अदर. तीसरा फंडा आएगा कि अगर मॉड z माइनस z1 इज इक्वल टू a आ जाए, इज इक्वल टू कांस्टेंट हो जाए, तो मतलब क्या हुआ इसका कि भाई एक ऐसा पॉइंट z है जो z1 से हमेशा कांस्टेंट डिस्टेंस पे रहता है. सोचो एक पॉइंट है, दूसरा पॉइंट इससे हमेशा इक्वल डिस्टेंस पे रहता है. क्या हुआ? सर्कल बन गया, which means this will represent a circle. These are the 3 concepts you need to use in. Yeah, so if there were only 2 points, again same बात होती. How many? If there are 2 points, then you're saying अच्छा, very good question that Anshuman has, right? Anshuman says अच्छा ये supposing ये तीसरा नहीं होता, सपोजिंग तीसरा पॉइंट नहीं होता. वेरी गुड क्वेश्चन, राइट? सो आई हैव z, z1 and z2, and I have z minus z1 in the modulus is equal to mod of z minus z2, right? So which basically means the distance PA is equal to PB. तो मैं इमेजिन करता हूं 2 पॉइंट है A और B, ठीक है, और एक ऐसा पॉइंट है जो A और B से इक्विडिस्टेंट है. तो इमीडिएट रिएक्शन तो आएगा कि भाई इन दोनों का मिड पॉइंट होगा. So does that mean 1 point? But then there is a problem, no? Because अगर मैं मिड पॉइंट पे एक परपेंडिकुलर बना दूं तो इस परपेंडिकुलर पे कोई भी पॉइंट कंसिडर कर लो, लेट्स से Q कंसिडर करो और ये ट्रायंगल बना दो आप, तो कैन आई से दैट दीस टू ट्रायंगल्स आर कॉन्ग्रुएंट? कैन यू प्रूव देम? देखो बाय कंस्ट्रक्शन आपने मिड पॉइंट बनाया है, ये कॉमन है दोनों ट्रायंगल्स में और ये दोनों एंगल्स में 90, दोनों ट्रायंगल्स में ये एंगल 90 डिग्रीज है, which means that there will be these two triangles will be congruent by the SS rule. The moment they are congruent, these distances will also be equal. So you won't have one such point. You'll have in an entire straight line, all points will be equidistant. So अगर दो ही पॉइंट होते तो आंसर होता there are infinite such possibilities. There are infinite such possibilities. Now don't ask me what happens if there were 4. Yeah. Well, absolutely. Some of you are asking me, sir, ये क्वेश्चन छोड़ देंगे इस टाइप का? बिल्कुल छोड़ सकते हो यार, absolutely. But if you can make sense out of it, ना ये क्वेश्चन वो है जो बहुत ज्यादा लोग नहीं करते हैं, right? So it could, and you know, इस पे सोल्यूशन कोई बड़ा तो नहीं है ना, आपका दिमाग ज्यादा लग रहा है, not so much of writing on paper, right? So I agree though, most of you will find this hard, so you can leave this question, right? इस टाइप के क्वेश्चन को छोड़ सकते हो, कंफ्यूजन अगर लग रहा है तो, right? But for my part, I will make sure कि at least थोड़ा बहुत भी समझ में आ गया है तो इसको प्रैक्टिस कर लेते हैं, right? Let's look at a few more questions like this. Look at question number 11. Right? Look at question number 11. It says, I'll give you 1 minute to think about this and then solve. Right? इसका फंडा भी बता देता हूं. क्वेश्चन नंबर 11 का ये वाला फंडा है ये. Whenever mod of z minus another z minus z1 is equal to constant आ जाए, जो यहाँ हो रहा है ना, you have mod z2 minus 3 plus 3 minus 4i is equal to 5. तो ये actually circles हैं. So you'll have to use that funda. देखो इस क्वेश्चन को सॉल्व करने का लॉजिक ये है, राइट? इन कोऑर्डिनेट ज्योमेट्री you have points, right? Then you have straight line and then you have a circle, right? For points correspond to in this case Z, right? Each point can be written as Z1, Z2, Z3. These will all be points, right? Straight line for now, don't worry, right? Because in general, when you have a straight line, it will have multiple points, right? So a straight line will basically have a Z which is not a constant. But forget about straight lines अभी के लिए, right? Straight line के लिए अभी ज़्यादा सोचो मत, right? Straight line पे question नहीं आता है, right? But circle पे question काफी बनता है, right? So a circle is always represented as mod Z minus Z1 is equal to R. इसको ऐसे समझो आप, right? Here Z1 is a fixed point. In fact, this point will be the center, and Z is a locus. If you guys understand locus, right? Z is the point of locus. Z can take infinite points on the plane, right? Why? Because what does mod Z minus Z1 represent? It represents, let's say this is the locus of P and this is the center O, right? Mod Z minus Z1 will actually be distance OP. And if that distance OP needs to be a constant R, how many points can you find like that? सोचो कि ये रहा एक point Z1, ठीक है, और इस Z1 से R units distance पे मुझे infinite points मिलेंगे ना ऐसे, तो वो circle बन जाता है. If this is a circle of radius R centered at the point Z1, then the equation of the circle is mod Z minus Z1 is equal to R, right? And remember, Z is not a constant, Z is a variable. The Z will be X plus IY. Think about it that way, right? So mod of Z, सोच के देखो ना, equation बना के देखो, Z is X minus IY, X plus IY, and Z1 is let's say A plus IB. तो मेरा mod क्या equation क्या बन रहा है? Mod of this is equal to R, right? Mod का फॉर्मूला क्या होता है? Root of real part X minus A whole square plus imaginary part Y minus B the whole square is equal to R. तो अगर स्क्वायर रूट हटा दोगे तो ये इक्वेशन ये बन रहा है. अब कोऑर्डिनेट ज्योमेट्री में ये देखा हुआ लग रहा है? Does this look familiar from coordinate geometry? This is a equation of a circle which has a center at A comma B and has a radius of R, right? So this is equation of a circle. If you work backwards, this is the equation of a circle, right? So next time you should remember it. Should remember mod of Z means distance from origin. Mod of Z1 minus Z2 means distance of Z1 plus Z2 from Z2. But mod of Z minus Z1 equal to R is equation of a circle centered at Z1 having a radius of R, right? So this is what I need to keep in mind. Now in this question, what am I given? In this question, what am I given? I am given, देखो conditions देखते हैं. It says first that mod Z1 is equal to 12. देखो Z1 लिखते ही आपको समझ में आना चाहिए ये constant है. This is not a varying point, right? So Z1 is equal to 12. Sorry, doesn't need to be a constant because there are two equations given, no? So it doesn't have to be a constant, right? Mod Z1 equal to 12 means I can write this as mod of Z1 minus 0 is equal to 12, which means this is a circle with center at origin and radius 12, right? So that is given to you. So that which means कि अच्छा एक circle बना हुआ है, center origin उसका है और center origin पे है and it has a radius of 12. There's one more complex number Z2 where mod of Z2 minus 3 minus 4i is equal to 5. Am I written correct? Yeah, I've written it correctly. Which means I can write this as Z2 minus 3 plus 4i. So this is like Z2 minus Z3 is equal to 5. So Z3 will be the center and 5 will be the radius. So this is another circle with center at 3, 4 and radius 5. Correct? The moment I understand this, अभी तक हमने कुछ equation नहीं बनाया है, but समझ लिया इसको, right? If you understand this, let's make this, let's plot this. So one has origin at 0, 0 and big radius 12, right? The second one has center at 3, 4, okay, somewhere here, and it has a radius of 5. By the way, 3, 4 अगर आप imagine भी करोगे ना, तो उसका डिस्टेंस सेंटर से कितना होगा? 3 स्क्वायर प्लस 4 स्क्वायर. What will the distance O2 let's say is the center? This is O, this is O dash. तो O dash का distance O से क्या हुआ? It will be root of 3 square plus 4 square. It turns out that's 5. So यही radius है. तो अगर ये radius है तो circle जो बनेगा, circle जो बनेगा वो ऐसे कुछ बनेगा. It will be a circle which passes through 3, which has center at 3,4 and passes through origin. है ना? यही बना. अब question ने क्या मांगा है? For all complex numbers Z1 and Z2 that satisfy these two, which means that lie on these two circles Z1 and Z2, the minimum value of mod Z1 minus Z2. अब जैसे ही आपने देखा mod Z1 minus Z2, आप कहोगे Z1 एक पॉइंट है, Z1 इस सर्कल पे लाई करेगा, Z2 एक और पॉइंट है, वो सॉरी Z1 बड़े सर्कल पे लाई करेगा, Z2 छोटे सर्कल पे लाई करेगा, but these both will be points and mod of Z1 minus Z2 will be distance of PQ, right? Where P is a point here, Q is a point here. तो मुझे इस डिस्टेंस का मिनिमम वैल्यू निकालना है. बेसिकली इस सर्कल पे कोई भी एक पॉइंट ले लो और उस सर्कल पे कोई भी एक पॉइंट ले लो और उनका डिस्टेंस मिनिमाइज करो तो क्या आएगा, राइट? एंड द मोमेंट यू लुक एट दिस फिगर वो थोड़ा सा ऑब्वियस हो जाता है, राइट? क्योंकि डिस्टेंस अगर मिनिमाइज करना है तो ये जो O1 बनाया आपने, राइट, इसी को अगर मैं बाहर एक्सटेंड कर दूं तो इससे छोटा डिस्टेंस तो कहीं मिलेगा ही नहीं मुझे, right? And if you think about it, what this is P and this is Q. What is OQ? What is OQ? From origin to the outer circle will be its radius 12. Similarly, what is OP? It is the diameter of this circle. इस सर्कल का डायमीटर क्या है? सर्कल का रेडियस 5 है तो डायमीटर 10 होगा. तो भाई अगर मुझे मिनिमाइज ही करना है ना यहाँ पे, हाँ, अगर मिनिमाइज करना है तो 12 में से 10 घटा दो, आंसर यही आ जाएगा. PQ min value will be 12 minus 10, which is 2 units. So that's my answer. Does that make sense? हाँ, ये थोड़ा सा टेढ़ा है, but I hope that you guys are able to wrap your heads around it, right? This is a little obtuse, but 3 concepts, as I said, मैं बार बार रिपीट कर रहा हूं वही. Mod Z1 मतलब distance of a point from origin. Mod of Z1 minus Z2 will be distance of point A from point B. And mod Z minus Z1 is equal to R is the equation of a circle. It represents all points that lie on a circle, right? On the circumference of a circle. All points equidistant from a given fixed point. That's a circle. तो अगर आप मैक्सिमम डिस्टेंस 22 कैसे आएगा? इन थियोरी में भी, बट इन प्रैक्टिस मैक्सिमम डिस्टेंस तो रेडियस होगा ना. You extend it backwards and this will be the maximum distance, right? That will be the radius 12. So minimum distance is 2, maximum distance will be 12. It has to lie between 2 and 12. Is that clear, guys? Yeah, I know this. Let's try this in one more question. अगले question में try करो. For all complex numbers Z1, Z2. ओए, same ही question है. Okay, ignore. Okay, try 13th. यार अब complex numbers इतना straightforward होता भी नहीं है ना. So see then, you know what? I think the general rule that you guys should keep, right? Forget कि अब मैंने आपको टफ चीजें पढ़ाई भी हैं, right? देखो, मतलब किसी भी कॉम्पिटिटिव एग्जाम के लिए ना, there is one basic level of intellect and then there is slightly advanced intellect. ठीक है? Intellect में ना difficulty level of questions की बात कर रहा हूँ. So to clear cutoffs, you never need to do the hard questions, right? Cutoffs usually, if you clear it, to clear it, you just need to attempt the easy level of questions, the easier variety of questions. तो कट ऑफ क्लियर करने के लिए इस टाइप का क्वेश्चन नहीं करना है, राइट? बट अगर थोड़ा सा टाइम लगा करके अगर आप ये क्वेश्चन सीख जाओ और ये एग्जाम में आ जाए इस टाइप का, राइट? दिस इज दैट काइंड ऑफ क्वेश्चन व्हिच मींस दैट यू विल नॉट जस्ट क्लियर द कट ऑफ, यू विल स्कोर वेरी हाईली इन द एग्जाम, राइट? ये आपका स्कोर बूस्टर है, थिंक अबाउट इट दैट वे, राइट? बट द बेसिक्स आर मोर इंपॉर्टेंट, रिमेंबर. अगर ये टफ लग रहा है, कॉम्प्लेक्स नंबर मत छोड़ना. You must still be attempting questions that involve modulus and, you know, argument, right? Basic level ke questions. I think you still should do that. Okay, I'm going to discuss one more question. Let's try 13th. Same funda use karo. Z is a complex number such that mod Z is greater than equal to 2. इसको समझते हैं. देखो यहां दिया हुआ mod z is greater than equal to 2. देखो अब इसको समझो, mod z equal to 2 क्या होता? What would this represent? What would mod z equal to 2? What do you think that represents? Mod z represents distance of a point z from the origin. So this represents OP. And this represents OP is equal to 2. And what is OP equal to 2? Distance of a point P from the origin must be a constant 2. So this represents actually a circle. Mod Z equal to 2 is कि origin पे center बना लो, radius 2 ले लो, एक circle बना दो. So mod Z equal to 2 is this circle. Mod Z greater than equal to 2 will be this circle and all points outside it. Yeah? Make sense? अगर mod z equal to 2 circle है तो greater than will be outside the circle, less than will be inside the circle. So mod z greater than equal to 2 means all points that either lie on the circumference or lie outside it. Fair enough. Okay. What else is given? Then the minimum value of mod of, अब देखो इसको अलग से लिख लेते हैं, mod of z plus 1 by 2. अब यहाँ पे equal to something नहीं है, तो इसका क्या मतलब हुआ कि एक z है और एक ये, इसको z1 सोचते हैं. राइट, इनफैक्ट इसको ऐसे लिखना चाहिए आइडियली, z माइनस माइनस हाफ, इसको ऐसे लिखो और सोचो ये z है और ये z1 है, तो इसका क्या मतलब हुआ? व्हाट डज दिस यू नो रिप्रेजेंट? दिस रिप्रेजेंट्स द डिस्टेंस ऑफ पॉइंट P represented by z from another point Q represented by z1. So this is question is saying भैया एक फिक्स्ड पॉइंट है -1/2. कहां होगा ये -1/2? अगर ये मेरा इसी प्लेन पे आ जाते हैं वापस, राइट? इससे को मिटा लेता हूं, राइट? सो इट डजंट कंफ्यूज अस टू मच, राइट? सो दिस इज द xy argand plane, राइट? Sorry, imaginary part of z and real part of z. So one, I have a circle like this. Okay, this circle has a radius 2, which means this will be 2, 0, 0, 2, minus 2, 0 and 0, -2. Correct? 4 points on the you know on the axis, right? And then I have a point z1. Where is this z1? इसमें कोई imaginary part नहीं है, which means this will lie on the real axis at -1/2. तो ये रहा 0, ये है, ये -2 है, ये -1 होगा, ये -1/2 होगा. So this is the point Q, which is -1/2, 0. Right? This is the point Q. This is O. Right? And you have Z, which represents the distance of. अच्छा यहाँ पे P लिख दिया है. P क्या है? ये यही point Z है ना? तो P will be a point on the circle, right? And you are wanting to. Your question says find the minimum value. या P जो है, sorry, Z जो है greater than equal to 2 है, not equal to 2. Z greater than equal to 2 है, which means the point P, which represents the same Z, will either lie on this circle or lie outside it. है ना? या तो सर्कल पे लाई करेगा, सर्कम्फ्रेंस पे, या उसके बाहर लाई करेगा, वो P है. Q मेरा फिक्स्ड है ये रहा. और क्वेश्चन बोल रहा है फाइंड द मिनिमम डिस्टेंस ऑफ द पॉइंट Q, find the minimize the distance of the point P, which lies either outside or on the circle, from a fixed point Q, which is ये रहा, which is at -1/2, 0. So obviously you'll choose the minimum distance, which is you'll choose P over here. And you say okay, ये distance कितना है? ये total 2 था और ये 1/2 है, तो बाकी का डिस्टेंस बचा 1.5, 1/2, 1/2. Answer is 3/2. That's your answer. So what is the minimum value of Z plus 1/2? 3/2. Is that there in the option choices? right? It lies in the interval 1, 2, nahi. Is equal to 5 by 2, no. Is strictly greater than 5 by 2, no. Is strictly greater than 3 by 2 but less than 5 by 2. Ideally D is also incorrect here. It should say is strictly greater than or equal to 3 by 2. Right? The minimum value is in fact 3 by 2. No. अंशुमन स्क्वायर क्यों करोगे? डिस्टेंस तो डिस्टेंस होता है, स्क्वायर क्यों करना है? This is the distance, no? Think about this. This is minus 2, 0. This is minus 1 by 2, root of minus 2 plus 1 by 2 the whole square plus 0 minus 0 the whole square. यही करोगे ना? तो कितना आ रहा है ये? 2 minus 1 by 2 is minus 3 by 2. Minus 3 by 2 का square root will be 3 by 2 only, na? You'll square it and then take a square root. It will come back to 3 by 2. So you don't need to square it. अगर आप coordinate geometry से कर रहे हो तो directly distance ही तो निकालना है. You don't need to square and everything. But if you are using coordinate geometry by using the formula, distance formula, then it will be square root of a minus b whole square plus, x2 minus x1 whole square plus y2 minus y1 whole square. उससे भी same ही answer आएगा 3 by 2. Yeah? This is an obtuse topic. I know these questions sound a little hard, but please try and apply. Some of you should try and use these slightly different ways of looking at complex numbers in terms of coordinate geometry. थोड़ी सी आदत डाल दो अगले एक आध हफ्ते में, and this just might be a bonus question for you, right? बाकी questions हो जाते हैं यार. Complex numbers is not that hard a topic. I think if you can just do the basic ones involving the modulus, argument and whatnot, and try and do these coordinate geometry kind of questions, applications. Nothing else needs to be done. In fact, even from this is a really hard exercise, right? Even from this exercise, I would say, maybe after question number 18, 20, 21, 22, 23, these are all really hard. ये सब क्वेश्चन तो आप वैसे भी एग्जाम में छोड़ देना, right? But till 17, if you try questions till 17, I think that's still doable, and that will be by using the concept of coordinate geometry. Yeah. Okay, guys, that was just to sort of flavor complex numbers पे. I deliberately chose this path, right? I know I disappointed maybe some of you. Attendance देख के भी समझ में आ रहा है. I think we're down to half the number of people who joined, right? I don't know, maybe that means that I should have kept my session a little simpler level, but because this is IPM level, I deliberately chose to sort of expose you to slightly hard problems. ठीक है? But definitely not to discourage, right? Again मैं बोलूँगा easy question पक्का करने हैं, tough question हो जाए तो कर लो, नहीं तो maybe work harder. Yeah. Okay, that's it for today, guys. Thank you. Have a great day. Again, for those of you who are who haven't subscribed to our channel yet, please click the icon below and subscribe to our channel. There's tons of such questions that we're going to keep posting. The the IPM test series offer is still on, guys. Click on the link in the description. Please access the class exercises as well as IPM mocks. 5 IPM mocks we are giving away for free. These are mocks that are extremely effective. So do subscribe, do avail of this offer, and I'll see you guys next Tuesday. Till then, thank you and have a great week.